Hi guys, today I'm going to be showing you guys how to do a question from Energizing Physics lesson 3.5. So the question asks, first to draw the free body diagrams as this person is falling. So in the first situation where the person is free falling, we know that the only force acting on the person is the force of gravity. And in the second scenario, we know that there is now gravity and a normal force. And in the third scenario, there's also gravity and the normal force. And in the last scenario, there's gravity and also a normal force. So we know the magnitudes of the arrows because in the last scenario, it's given that the scale reads 800. And we know that this is when the person is at rest, so the normal force here is going to equal the same force as gravity. So the net force is 0, which is why they're at rest. So here we can label the Fg is equal to 800 newtons. And then Fn is also equal to 800. So for all of these, we can label Fg as 800. And in the second and third scenario, we see that the scale reading is 2,500 newtons, and that's what the F normal will be.
So, in part B of question 11, we have to find MJ's height at the lowest point in his drop. And so, you're given that G equals 10 newtons per kilogram. His initial height is 2 meters. His second height is 1 meter. The scale reading at rest is 800 newtons. And the scale reading when falling is 2,500 newtons. Right? And so as I stated before, we were trying to find height 3. And so the important equations to keep track of are that E1 plus work equals E2, that GPE is equal to mgh, and that work is equal to force times displacement. And so, when solving, first we should solve for mj's mass. And so in order to do that, mass is equal to the scale reading at rest divided by g. So thus, mj will weigh 80 kilograms. And so, secondly, we have to fill in the types of energy that are present at point 1 and point 2, and also what work is done. And so, at point 1 and point 2, there's only GPE, because mj is at rest. And the work that is done is the normal force. The work done by the normal force. And so GPE1 is equal to height at point 1 times mass times g. And so work is equal to the reading on the scale times the displacement. And so displacement here is going to be 1 minus h3, because MJ starts touching the scale at 1 meter, and he moves between 1 meter and h3. And so that's the time where the force normal is going to apply. And finally, GPE2 is equal to h3 times mass times g. And so, solving this out, we get that 1600 minus 2,500 plus 2,500 H3 is equal to 800 H3. That 1,700 H3 is equal to 900, and that H3 is equal to 0.53 meters.